I set out to do what initially looked like a straightforward vintage Mac motherboard repair. But before I knew it, the whole thing spiraled out of control and turned into a project that took on a life of its own. My friend Jerry gave me a Macintosh SE 30 motherboard that was in rough shape. It was showing the aftermath of a clock or PRAM battery leak, along with the typical effects from failed electrolytic capacitors. While it did seem possible to repair this board, doing so would likely take a lot of time and effort, and there would be no guarantee of success. The SE30 is a fan favorite among vintage Mac collectors as it was an oddly powerful all-in-one computer for its time. Problems like the ones on this board are sadly commonplace these days, and you can go down quite the rabbit hole finding and fixing the tiniest bits of circuit board damage and corrosion keeping it from working. I wanted to find a more effective solution. Turns out such a thing exists in an open source project called the SE30 Reloaded. It's a recreation PCB drawn up by a German electronics wizard who goes by Bola. In theory, you only need to get one of these boards, transplant all the components, and off you go. A working SE30. At the time, nobody had any of these PCBs available for sale, so I'd have to get one manufactured myself. The minimum order quantity at most circuit board fabs is 5, though, and I wanted to have at least all the small passive components on the bottom, colloquially referred to as birdseed, added at the factory, since soldering them by hand can be incredibly tedious. But that costs extra, particularly the one-time setup fees. I would need to leverage economies of scale in order to make this affordable. So I went out on a limb and set up a group buy on the Tinker Different forums. I crunched the numbers and found that 50 boards was the sweet spot, bringing the total cost to around $70 US each. That's not cheap, but still a reasonable number given how much time it would save versus trying to repair a damaged board. Clearly, I wasn't the only one interested in this project because in just a few days, all of the boards in the group buy were spoken for, and I was able to work on placing the order. When the box arrived sometime later, I was eager to get them sent off to those who ordered them. I was able to get in some customization, specifically black solder mask with gold-plated pads. In working with electrical engineering expert Kai Robinson, we identified a way to get a lot of the parts on the top side of the board populated as well, like common ICs, in order to reduce the amount of soldering one would have to do. Not all was perfect though. Due to the way they were wrapped for shipping, a few boards got damaged. Some of the surface mount capacitors were knocked off, taking their solder pads with them. Thankfully, I was able to get them all fixed, even though sometimes the results weren't the prettiest, and I kept the worst ones as the boards I'd bought for my own use. And before you freak out, these caps are solid polymer. They'll never leak like electrolytic ones eventually tend to. I got started with removing chips from the donor board. A few were socketed, but most were either through-hole or SMD soldered. But as I went, I realized that even the components weren't in great shape. Corrosion on the legs can creep inside the chip itself and damage it. And furthermore, did I really want to put ugly old chips on my nice new PCB? Not really. And so I went shopping. A lot of the chips on the SE30 motherboard are commodity parts, albeit from 1989. Yet there are suppliers out there who specialize in stocking old components, and I bought what I could. Some of the custom chips are available new old stock as well, but others are either not available or ridiculously overpriced, like these floppy drive controllers. I decided that going forward I'd use new parts whenever I feasibly could, and reuse old ones only when necessary. Unfortunately, I couldn't find new old stock CPUs, so I had to carefully desolder the old one, which sadly Apple hadn't bothered to socket. The PLCC chips needed hot air to remove, and while I was able to buy new replacements for some of them, I decided to salvage them all just in case. All the connectors and sockets are still available new, except for one. The external floppy drive port isn't being made anymore, so it would have to be transplanted over. The most challenging part to remove was the metal brace at the back of the board. This serves as both a structural support as well as a grounding point, and being made of steel, it's basically a giant heat sink when it comes to desoldering. But with a lot of patience, I was able to get it separated from the PCB so I could reuse it. Time to get the new reloaded board built up. Most of the PLCC chip locations were able to be fitted with sockets, but due to space constraints or manufacturing limitations, some still had to be soldered directly to the board. This was pretty time-consuming and tricky, so I got it out of the way first. The socketed PLCCs were, of course, much easier. They just snap in, like with the new old-stock Math coprocessor that I bought. From there, I moved on to through-hole parts. Normally, I would have transplanted the 3 resistor network ICs since they're out of production, but I found an open-source project for producing replacements. So I got another PCB order put in. Instead of encapsulated chips, they use SMD parts on a small circuit board, but they work just as well. Due to minimum order quantities, I ended up with quite a few, so I sent the extras out to the people in the motherboard group buy. And yes, of course, I went with black solder mask in order to match. Up next was the CPU. I wanted to install it in a socket, but read that doing so would be a bad idea since this one had been soldered to the board previously, and that could cause poor connections. I did drop in sockets for all the other through-hole parts that I could. Who knows if I'd have to swap chips later on. I populated passive components like the axial capacitors, then got the ICs snapped in. A tweak that Bola made to the reloaded PCB design was to place pads for 4 PLCC sockets, should you want to install ROM chips directly on the board. I wanted to reuse the original ROM sim, at least for testing, so that meant procuring an obscure 64-pin sim slot, which are incredibly still available new, along with 30-pin slots for the RAM. My preference was for black ones to match the board, but had to settle for these white ones since they're the only kind that come with metal retention latches. Plastic latches, like those on the original donor motherboard, have a tendency to break, and that can lead to intermittent connection problems. After hours of soldering and only the bare essential parts installed on the board, it was time to test if it actually worked. I pressed my known good SE30 into service to help. I borrowed its ROM sim and 4 sticks of RAM and got them snapped into the reloaded board. Here's a trick I learned to make testing these boards easier. The harness between the motherboard and chassis can be made longer by using a cheap ATX cable extension. One end hangs off the motherboard connector, but none of those wires are used anyway. I crossed my fingers and powered it on, but to my dismay, it didn't work. This pattern on screen is referred to as a semazimac, and generally means that the video circuitry isn't getting any data to process. RAM can often be a culprit, so I tried the other 4 sticks from my known good board, but got the same thing. I needed to check my work. I spent hours, mostly off camera, inspecting all my solder joints. I also tested all of the connections on the board for continuity, using an excellent recreation of the original schematics as a guide. The matrix at the end is a huge help for doing this kind of work. I found a couple of connections to touch up, but nothing obviously wrong, and the reloaded board still didn't work. I needed to get a better idea as to what was going on with the board electrically, and this diagnostic tool from Zigzag Joe is a great way to do that. It fits in the ROM slot and has LEDs to show activity on the system bus, something you'd otherwise have to do one line at a time with an oscilloscope or logic probe. It has a pass-through slot that I dropped a modern ROM sim into. More on that later, and I fired the system up. Blinking lights is right. The green LEDs on the left show promising signs. They're indicating that the CPU is alive but walking the bus because it doesn't have any data to process. And normally, more of the red LEDs on the right would be blinking, but they're not. After jumping into a group chat with Kai and fellow electronics experts Max, Tech Knight, and Bola himself, the consensus was that the glue chip was possibly at fault. It's a custom IC that ties the various parts of the system together, and perhaps mine, which I'd transplanted from the donor board, was bad. So I had to replace it. Kai was able to offer another donor board for the project. This one supposedly worked, but someone had clearly tried their hand at recapping it, using through-hole parts instead of surface mount ones. I got its glue chip removed and soldered into my reloaded board, but that didn't do it. The system still wasn't executing any instructions in the ROM. The next suspicion from the hive mind was the CPU itself, as it's possible there was some kind of internal fault that wasn't obvious. This gave me an opportunity to upgrade, as it were. By this time, I had found a new old-stock Motorola 68030 CPU in a ceramic package on eBay and jumped on it. This would also allow me to install a socket on the board, which, yes, are also still being manufactured. I carefully desoldered the original chip and got the socket put in its place, then soldered all the pins and installed my new CPU. Please, could this be it? Nope. Not even with the original ROM sim. I was out of ideas. Tech Knight kindly offered to take a look at the board for me, so I packed it up to send his way. But before I did, I shared high-res photos of both sides with the group to check out, and just after the package was picked up, Kai noticed something. Some of the parts on the bottom of the board caught his eye. Specifically, the row of diodes between the RAM slots had markings that didn't look right. When he got the board, Tech Knight found that, indeed, they weren't the right parts.
I wanted to check to see if this is a diode or a transistor, so we're going to check right here. That's not right. No. Nope. No.
I confirmed the bill of materials I uploaded to the PCB manufacturer was correct, so at some point when they were being made, the wrong parts got installed at the factory. I'm not sure if it was my mistake or theirs. I had dozens of parts to juggle amid supply chain shortages, but they could have just as easily loaded the wrong spool onto the pick-and-place machine. Regardless, Tech Knight installed the correct diodes and sent the board back to me. And yeah, of course, that was it. My troubles weren't due to my soldering skills or defective components, but rather a manufacturing error. Tech Knight did notice that one of the new old-stock serial controller chips I had installed was bad and replaced it for me, but that wouldn't have caused the problems I was seeing. Let's finish getting this thing assembled then. It was a huge relief to know that the board was working, and I ordered the correct diodes to send to all the people in the group buy since their boards were likely affected too. After an odyssey of many months getting this board manufactured and assembled, the end was finally in sight. The reloaded board has provisions for a CR2032 coin cell holder instead of the original 1/2 AA, so this should keep future battery leaks at bay. With my external Blue SCSI connected, the board booted successfully and showed all the RAM I had installed. I fired up a diagnostics program called MacCheck, but after a while, I noticed some artifacts showing up on screen. At first, I panicked, thinking I had another major board defect on my hands, but after some research, learned what was really going on. As it turns out, there is an error in the design of the reloaded board related to the video circuitry. But early production SE30s had the same problem, which was fixed at the factory by cutting a trace and adding a bodge wire. Problem is, that fix never made it into the schematics Apple published, and it was those schematics Bola used when laying out the reloaded board. The good news is that means the same fix could be applied here too, and apparently is only necessary if you have a certain combination of chips, as Apple leveraged multiple vendors. To make it less noticeable, I did the bodge on the bottom of the board, and sure enough, that fixed it right up. No more video artifacts. The SE30 reloaded board was done and working. But it got me thinking. It'd be a shame after all that work just to stick it in an otherwise original machine. It deserved more. And thus, the rabbit hole got much deeper. My friend K. Koba from Caro's Mac Mods kindly sent me a few goodies, all with his signature Satanic Mac Club branding. First was a set of blank PCBs for creating your own RAM modules. 30-pin SIMs in large capacities are pretty sought after. So the idea is that you can take a single 16 megabyte, 72-pin stick of memory and turn it into a set of 4 30-pin modules of 4 megabytes each. Across the 8 RAM slots in the SE30, you'd end up with a very healthy 32 megabytes. With the chips desoldered from the donor RAM, I got them installed on the new modules along with a few tiny capacitors. It was repetitive and a bit tedious, but admittedly a great way to get more practice with soldering surface mount parts. When they were done, I snapped off the little extra bits of PCB that were left from the manufacturing process, then threw them in my ultrasonic cleaner to take care of any leftover flux residue. My attention turned next to the ROM. When testing the motherboard, I sometimes used a Big Mess of Wires ROMinator, which is a replacement module that has flash chips so you can reprogram it. These are popular among SE30 owners as it lets you use what's effectively the ROM from a Mac 2SI, a later machine that has a similar architecture to the SE30 but fixes some of the limitations, like adding 32-bit addressing. It works great, but I wanted to keep it for troubleshooting purposes, so I went with this instead. It's the Caro's Mac Mods take on this concept, and while it works in a similar way, it's implemented a bit differently. Like the ROMinator, it offers a capacity of 2 megabytes, but the flash chips are socketed so you can use any generic IC programmer to write new code to them. There's a companion app called Crucible that helps you build custom ROM images. You can modify the startup Happy Mac icon and also add a ROM disk. This is another major benefit to using a recreation ROM sim. The space left over on the chips can hold a small bootable disk image, and Crucible has a couple default ones built in. But if there are specific programs you want to add to the image, you can certainly do that too. Crucible will take the resulting file and split it into 4, one for each chip, or let you slice up or combine other ROM images that you may get from the internet. It takes all the guesswork out of setting up a custom ROM exactly how you want it. While I have a chip programmer, a simpler solution is to buy one that's designed for use with these ROMs, like the ROMmate from KMac Vintage, which cost me about $75. It connects through USB and uses the Sim Programmer app to read and write the data. What's nice is that you can take the custom ROM chip files from Crucible and drop them into Sim Programmer. Since all these ROM sims generally work the same way, ROMmate is compatible with a variety of them, including the monster 8 megabyte module that KMac also sells. Instead of a mechanical hard drive, I wanted to install a BlueSCSI, a popular solid-state hard drive emulator. I got one put together, but in the process, it gave me an idea. It would work great with another item K. Koba had sent called Belith's Drum, which cleverly uses a relay to simulate the noises you'd normally get from a mechanical drive. Usually you'd install it somewhere in your system and connect it to the BlueSCSI with wires, but I had other plans. I desoldered the activity header, then replaced it with a couple leads. The middle pin isn't otherwise used, but it's in a strategic location for me to connect to the ground pin with a careful bend in the lead. I whipped up a mounting bracket that I could 3D print, then dug through my bin of screws, all brand new of course, to find ones that would work. The bracket got secured to the BlueSCSI, then Belith's Drum was screwed to the other side, with those leads conveniently poking right through the BlueSCSI's activity LED connections. A couple quick solder joints later, and I had a BlueSCSI with a built-in noisemaker. Another of Kay's kits called SCSI Rider would take things even further. It's a simple adapter to plug a blue SCSI directly into a Mac's motherboard, so I wouldn't have to worry about ribbon cables or mounting brackets. It didn't take long to put the pair of connectors in place, and this likewise would also be a great project to practice your soldering skills. At this point I needed, well, an SE30 to install all these new goodies into, and my friend Steve was able to help out. It's an SE30 housing, CRT, and analog board with a spare power supply and floppy drive thrown in. As is, this would work fine, but I'd gone sufficiently off the deep end. Now I wanted everything in the Mac to be brand new, at least to the extent that I could pull off. So I bought something else from Kay, another Satanic Mac Club part that would again push my comfort level when it comes to electrical engineering. It's called the SE Analog Board Resurrections, and it's similar to the Reloaded board I assembled, but instead for the circuitry that drives the CRT. I've normally shied away from working on this kind of stuff, partly due to the high voltage surrounding CRTs, and partly because of the voodoo that makes them work to begin with. But it was time to face that fear head on. Some parts would definitely have to be transplanted from the original analog board because they're just not being made anymore, most notably the flyback transformer. Kay publishes a basic list of parts required for the board, but it's up to you to pick the specific components. So I hoped I hadn't made any mistakes with my parts order. Oops, too late. Actually, assembling the analog board is simpler than the motherboard since it's all through-hole parts. It's also a single-sided board, which means I got to install in some places a pretty amusing component called a 0-ohm resistor. Basically, just wire links. These are used when a connection needs to cross over some other traces. Usually a piece of wire is fine, but I ordered the proper parts for the sake of completeness. There's a driver IC under a heatsink on the old board, and I managed to find supposedly new old stock replacements on eBay. This was a bit of a gamble since fake parts are definitely a thing, but worst case, I could transplant the original one if they didn't work. There were more parts available new than I was expecting, but there were also some surprising omissions, like these potentiometers that I needed to clean up and reuse. Just as I finished the soldering, I noticed a mistake. I had misread the parts list and ordered a polarized capacitor for position C15. This one needs to be non-polar instead, and there's two choices. The original part is no longer being made, so most people will end up needing to use a film capacitor. But the lead spacing on these is wrong, so they won't drop into the board directly. It's possible to bend the leads to get it to work, and this is pretty much your only choice if you're recapping an original analog board. But Kay kindly included in the package an appropriate radial capacitor that fits correctly. They're out of production and only 85° rated instead of my preferred 105, but I decided this is the way I'd rather go. A newer revision of the Resurrections analog board includes through holes for both types of capacitor, so if you choose to build one of these, just go with the film cap for simplicity. Dealing with the fan was up next. The original one was probably fine, but these were always a little on the noisy side, so I opted to replace it with a modern one. For some reason, Apple chose to place the connections on the other end of the board, so normally you'd end up with some messy wiring. But I had another idea that would look much cleaner. The bummer with Noctua fans is there's no way to access the solder connections on the motor without damaging it. It's not possible to take these apart. So I had to splice the existing wiring, and I clipped off the speed control line since it wouldn't be needed. Cable sleeving and heat shrink tubing left me with a nice looking solution, and when put in place, it's a lot tidier than the original fan setup. These CRT yoke connectors can get discolored over time, but they're just a standard part that's still available, so I could remove the old one and snap the pins into the new housing. And to finish up the analog board, I put together the new CRT neck PCB that also came with Kay's Resurrections kit. I moved on to the power supply. At the time, no one had made a replacement PCB for these, so all I could do was take it apart and fix anything that needed attention. Capacitors are of course the main concern, and I decided to replace them all out of precaution. Well, except for this big one on the primary side. In general, failures in these are uncommon. And sure enough, after examining and testing all the rest of the old caps, they turned out to be just fine. Just my luck, not long after that work I stumbled across a new project. A replacement PSU board, but instead of being a direct clone, it leverages modern components. It's from Babyface Electronics, and honestly, at $135, the price is a little on the high side, but I couldn't say no. Normally you would reuse the AC input socket and power switch, but this whole computer is anything but normal, so I bought replacements for those too and got them wired up. I stole some wiring from a power cable, and to keep things looking tidy, I made sure to protect the connections with heat shrink. The switch snapped into the PSU housing just fine, but the AC socket was a bit loose, so I whipped up a 3D printed spacer, and that took care of it. The DC wiring bundle going to the analog board came with a grommet already installed, but this assumes you'll be putting the cover back on the PSU. I'm not doing that, so I transferred over the original grommet, which clips to the case instead. Overall, this is a neat solution if your original power supply is completely dead, and the only oversight I can see is that, well, the silkscreen is upside down. All these new, nice-looking parts weren't going to be hidden away inside some boring beige case, though, were they? Of course not. Steve hooked me up with another key piece for this project, a clear reproduction SE30 case from MacFX. The story behind these is a journey in itself, but in short, Steve ended up with an extra because this one isn't quite perfect. The initial production run had some issues with the plastic being hazy, so replacements were sent to everyone who ordered one. But I had read that it was possible to at least improve the clarity of the case by polishing it. I chose to go with some automotive scratch remover, which proved time-consuming to apply because of all the nooks and crannies in the case. I had to polish both sides, and while it didn't produce perfect results, it certainly did help. And of course, since you'd now be able to see them, I had to order all new stainless steel hardware as well. All that was left then was to put it together. To say I'm thrilled with the results is an understatement. Not only do I love the way this SE30 turned out, I'm hugely relieved that it even works at all. Other than that diode issue with the motherboard, everything else just worked fine on the first try. It's also insane to think that this Mac, which debuted in 1989, is made up of mostly brand new parts. Other than the floppy drive, I really just had to reuse some components here and there, the metal framework, and the CRT itself. It certainly wasn't quick or cheap. I spent over a year and about $1,000 pulling this thing together. But you know what? It was worth it. I built this for 2 reasons. First, to try something I'd never done before. Before this, I'd never had circuit boards made, never had to learn so much about different electronic components, and never had to do such extensive soldering and rework. I'm still by no means an expert, but I've gained a lot of confidence in my abilities. But also, this is a showcase of the amazing things the vintage computing community is capable of. We're far past simple replacement parts and deep into the weeds of electrical engineering and circuit design. The SE30 Reloaded board is only one of many motherboard reproduction projects, for example, and they're not just limited to Macs. New projects are popping up all the time, like the alternative power supply option that launched not long after I bought the one I used in this machine. The options aren't quite endless yet, but we're quickly getting there, thanks to folks like Bola, Kai Robinson, K Koba, Max, Technite, and all the others who helped me with this project. As long as there are people with knowledge and initiative, it's becoming clear that these old computers will simply live forever. If you liked the video, I'd appreciate a thumbs up and be sure to subscribe. Here's another episode you should check out, and as always, thanks for watching.